All right, hello RSLE and
Oh, darn.
whoever's watching this video. We are doing 3-8. There are 10 sections to this chapter, so we've got 2 more after this one, so 3 left. Slopes and equations of lines. This is taking us back to algebra. This is exactly an algebra like lesson, so it should be review.
Are you still recording?
Slope. I am recording.
This little thingy.
Right there. Yep, he's good. He just went away. He should go away. Maybe. Now he's not gonna, because you said that. There we go. Okay. So slope. Going back to slope. What symbol do we use for slope? M. Okay. M is the rise over the run. Yeah. Rise over run. Okay. Or yeah, we are doing this in trig. Or how do you find the M if you're given like 2 points?
Y2 minus Y1 over X2 minus X1.
You betcha. X2 minus X1. Y2 minus Y1 over X2 minus X1. That's the way that it works, okay? Now, if you said Y equals MX plus B, that is slope-intercept form. We're going to get to that, okay? So this is writing the actual equation. This is just the slope. Okay, got it? And the slope is a part of the equation. Okay, so we're going to get to that. All right, now, let's talk about parallel lines. If I have 2 lines that are parallel, what do I know about their slope or their rise over the run?
They're going to be the same.
They're going to be the same. Does that make sense to you?
Yes.
Okay, so parallel lines, same slope. Shh. Parallel lines have the same slope. What are perpendicular lines again?
T.
They cross and they make
90 degrees.
a 90-degree angle in the corner, right? Okay, if 2 lines are perpendicular,
Reciprocal.
the slope equals negative reciprocal. Okay, the slopes are negative reciprocals for perpendicular lines. So if one of the slopes is 2/3, then the other one is what?
Negative 3 over 2.
Negative 3 over 2. If one of the slopes is negative 1/4, what's the other slope going to be? Shh. If one of the slopes is negative 1/4, what's the other slope? 4. Positive 4 over 1, right? If one of the slopes is negative 7 over 2, the other slope is going to be positive 2 over 7, right? If it's positive, you make it negative. If it's negative, you make it positive and you flip it, right? That's perpendicular, all right? So here we go. We are trying to identify if AB, which is a line, and CD, which is a line, if they are parallel, perpendicular, or neither, all right? And they give me points for this. So AB are these 2 points. We want to find the slope. So I'm going to do it up here. I'm going to call it M, but I'm going to do M with a subscript of AB so we know which one we're talking about. Do you see that? M of AB. All right, and we're going to do Y2, Y1, X2, X1, okay? So M of AB. What's your Y2 going to be? 2 minus
6.
over
Negative.
-9 minus
3.
3. Okay, let's do it. 2 minus 6 is -4 over
Negative 12.
-12. Now what?
Just make it
The 2 negatives cancel to make a positive, and that reduces to be 1/3. Okay, real quick, before we do the other one. If these 2 lines are parallel, what will the slope of the other one be? 1/3 also. If these 2 lines are perpendicular, what will the slope of that one be?
3 over 1.
Negative 3 over 1, right? Okay. If it's not any of those 2 options, then these are neither parallel or perpendicular when we choose this option, right? Okay. So let's decide. CD is the next one we're doing. Let's do M. M of CD, I'm doing a little subscript CD, okay? Y2, what do you got?
3.
Minus.
4.
Over.
2.
Minus.
5.
Okay, great. 3 minus 4 is -1. Over. 2 minus 5 is -3. And then what?
1/3.
Yeah, the negatives cancel, so that is 1/3. So I have 1/3 and 1/3, which is parallel. These 2 lines are parallel, okay? If you graph them, you can if you want. 3, 6. These are going by like 2s. 3, 6, and -9, 2 is this guy right here. So I have this line, and the other one, CD, is 2, 3, and 5, 4. This line right here. Evidently, those 2 lines are parallel. Ooh. Okay, you don't have to graph them, but that's consistent with our results. Got it? Okay, moving on. I don't know. Okay. All right, next one, example 2. Flip over to the next page. Flip over to the next page. Example 2. Determine line relationships when given a graph. We want to determine whether RS and TU are parallel, perpendicular, or neither. Okay? All right, but I'm going to do this by looking at the chart. You can, if you want to, figure out the M by using like the points. You can totally do that, but I'm going to just count. Here's what I'm going to do. I'm going to pick this dot and this dot, and so I'm going to find the M by just counting. This is M of TU. Okay? He is going down 3 blocks and over
It'll be negative.
2 blocks, so -3 over 2. That's what his slope is. Now, hold on just a second. Wait a second. We did this one, and then we realized, wait a second, they're going by 2s. So you're actually going down how much? 6, and you're going over.
4.
But does it matter if I do -6 over 4 or -3 over 2? That's what he reduces to. So if you have blocks, and they're going by numbers other than 1, you can seriously just count the blocks, right? Because it will then be reduced. So -3 over 2. All right. I want to find the slope then of RS. If these are parallel, what will his slope be? -3 over 2. If they are perpendicular, he will be 2 over 3. Well, they're obviously not parallel. I can cancel out parallel. They don't even look parallel. But are they perpendicular? I don't know for sure. Let's see. Okay? So we're going from this point right here to this point right here. And I'm just going to do it by counting. You can do y2, y1, x2, x1 if you want to. I'm going to go over and make a triangle out of this guy. So we do rise. How much is it rising? Each of these is going by like 2s. 4, 5, 6, 7, 8, 9, 10. Is he rising 10? Okay, and he's running 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Is it positive 10 over 14 or negative 10 over 14? Positive. That reduces to 5 over 7. So that's his slope. Are they parallel, perpendicular, or neither? Neither. They look like they might be perpendicular, right? But they are not. It's not a perfect 90-degree angle. Got it? Make sense? Yes? Okay. I'm going through this kind of fast, so stop me. They want us to do another one. B. Shall we do B, or are we moving on? Okay. Do you understand what we're doing? Finding slope to comparing? Okay. Let's go to the next one, which is talking about equations of lines. Equations of lines. We will only work in slope-intercept form. I don't teach point-slope form because you don't see it very often, if at all, on like ACT or whatever, and it's not a very usable form. So we only do slope-intercept form, which is y equals mx plus b. Do I need to go over the parts of that? Are we good to go? Okay, y equals mx plus b. All right. Now, we also have, in addition to those, sometimes you'll see horizontal and vertical lines. Okay, so like this one is a vertical line. You see him right here in purple? What's the equation of that vertical line?
Y equals 2, -2.
X equals -2.
E is x equals
Because
-2.
it's only
Now,
the X.
do you know why Matthew said y equals? Because the y-axis goes up and down, right? So it should be y. That's probably why you said that, right? Yeah, but it's actually x because it cuts through the x-axis, right? That's what it's cutting through, okay? So x equals -2. All right, now, this one right here, this yellow one, what's he?
Y is -3.
Y equals -3, okay? So that's what your horizontal vertical lines look like. Perfectly horizontal, perfectly vertical. That's what the equations of those are. Got it?
Pencil back.
All right, go to the next one. Example 3. We're flying right along. A says we are comparing now lines and determining whether they are parallel, perpendicular, or neither. The easiest way to do this is put them into slope-intercept form. So this is my first line, and here's my second one. The first line, is he in slope-intercept form already? Yes. What's his M? 3. His slope is 3, okay? If this guy over here is parallel, his slope will also be 3. If he's perpendicular, his slope will be -1/3. But here's the problem. He is not already in slope-intercept form. He is in point-slope form. So let's like fix him, make him perfectly slope-intercept form, and we'll see if he's, correct. This -0 is not doing anything.
Yeah.
Okay, correct? So we have y equals. Now I want to fix him on this side and make him not have any parentheses. What can he do?
-1/3 X.
Yep, he'll be -1/3 x, right? What's -1/3 times -2? Plus,
I don't know.
this is like 2 over 1, right? 1 over 3 times 2 over 1. What's 1 times 2?
2 over 3.
2 over 3, right? So this is the equation. What's his m? Negative 1/3. So I'm comparing negative 1/3 and 3. Are those parallel, perpendicular, or neither? They are perfectly perpendicular. So those two lines, if I were to graph them, would be perpendicular. They would form a right angle. Happy with that? Okay? All right, let's do B. B is this one. Y equals 3 and X equals 1. How the heck do I do that? How do I identify if these lines are parallel, perpendicular, or neither?
They're straight lines.
They're straight lines. Like Y equals 3 is 1, 2, 3, this line right here. X equals 1 is right here. Are those parallel, perpendicular, or neither? Those are perpendicular. Now, what if I would say Y equals 3 and Y equals 1? Are those parallel, perpendicular, or neither? In that case, they would be parallel because I would have Y equals 1 and Y equals 3. Does that make sense? So if it's the same one, then they're parallel. But if it's Y equals something, X equals something, then they're perpendicular. Got it?
Yep.
Okay? Happy with that? Can we skip C and D?
Yes.
Okay. Let's go to last one. Right here. Example 5. We're skipping right along. Okay? Because you guys, a lot of you guys are doing this right now in trig. Like, how many of you? 3 of you? 3 of you are in trig right now?
Yes.
Yeah. Yeah. Okay. All right. So here we go. Writing equations of parallel and perpendicular lines. All right. I'm going to do this work over here. So write parallel on this side. And write perpendicular on this side. Parallel, perpendicular. We're going to make parallel, perpendicular lines. Here is my original. Original goes at the top. All right, let me read the sentence. It says, write an equation. Shh, you gotta listen. We're on the last one. Write an equation in slope-intercept form. What slope-intercept form again? Y equals mx plus b. For the line that is parallel to this guy, we're going to do perpendicular as well so you can see him. Okay? But we want parallel and perpendicular. My original line is y equals negative 3/4 x plus 3. And then they give me the point. I'm going to put this off to the side. Negative 3 comma 6. Those are the 2 pieces of information it gives me. Okay? That's what I'm working with. I want to write a parallel line. And then we're also going to do a perpendicular one just because I know they're going to ask. Okay? All right, here's the deal. This guy right here, his slope is what? Negative 3/4. My original slope is negative 3/4. All right. If this guy is parallel, what does my new slope need to be? If this guy is going to be parallel to this line, what's my new slope going to be?
Y equals 4 over 3x minus.
No. If he's parallel, what's the
Oh.
new slope going to be?
Negative.
Also negative 3/4, right? If I'm going to do a new slope for perpendicular, what will my new slope for perpendicular be? Positive 4/3. You see how that works? Okay? So I'm just identifying my slope. So now at this point, I am at y equals negative 3/4 x plus what? What goes here?
3.
This number right here?
Yeah.
We don't use him ever.
Yeah. You plug
We
those
don't
in.
use the same
You
b.
plug those
We have to find b, right? Do you remember doing this?
Yes.
You scratch him off. You don't ever use the same y-intercept, okay? We have to find b. How do we find that b?
Plug it in.
We plug in negative 3, 6. This is where this part comes into play, right? All right, negative 3 is going to go in for x. So 6 goes here, negative 3 goes here. 6 equals, do you know what negative 3/4 times negative 3 is? It is like positive 2.25 plus b. Okay, now what do I do to solve for b? Minus 2.25. What is 6 minus 2.25? You can do that in your head.
What's 6? Oh, it's 3.75.
3.75, okay? So, final answer, what's the equation gonna be, the whole thing? Y equals?
Negative 3/4x plus 3.7.
Plus 3.75, perfect. That's my parallel line. So this line is parallel to this one, right? Now there's a reason why we scratch off that 3, right? If I used the 3,
It would be the same.
it would be the same line, right? Negative 3/4 x plus 3. I have to get rid of this 3, otherwise I would have the same line on top of itself, right? So that's not gonna work, okay? It's the same line. All right, now we're gonna do perpendicular. Perpendicular. I know that my new slope needs to be 4/3. So I'm gonna start with y equals 4/3 x plus
B.
B, and we gotta find the new B by plugging in negative 3 comma 6. So 6 goes here, negative 3 goes here. All right, 6 equals. Do you know what 4 over 3 times negative 3 is? This is like negative 3 over 1. So 4 over 3 times negative 3 over 1. Yeah, or the 3's will cancel, right? And it will just be negative 4. So negative 12 over 3 is negative 4, or you can just cancel the 3's and it will be like that. What's B gonna be? What will be B? B will be 10 if you add the 4, right? So B is 10, so the last one, Y equals 4 over 3, X plus 10, perfect. That was really fast. Was that too fast?
No.
Do you remember doing this in algebra? Yeah. Or in trig that we just had, right? Okay. All right, so homework is this guy. If you didn't write him down already, there he is, 9 problems.
Do we have to graph?
You don't have to graph.
Yes.
You don't have to graph. Okay.
You would.
All right. Good, good. All right. Goodbye, RSLE.